everyone, welcome to this video. In this video, we shall be looking at a question which appeared in IIT-JAM 2022 exam. Right, this is a 2-mark question and it is a numerical answer type question. So we have to tell the exact answer in this case. Now this is a very simple question taken from function of one variable. Here you are given two functions. The first function is given to be this f function, which is defined from 0 to infinity to r. Right, this function. For this function, we are given this condition that the integration from 0 to x cube plus x square f of t dt, that is equal to x square. This is given to us, right? And for the other function, which is given to be a function defined from the interval 0 to infinity to another interval 0 to infinity, that is positive real line to the positive real line. And for this function, we have this condition that the integration from 0 to this particular function of t square dt, that is equal to 9 times of x plus 1 cube, right? So now they are asking, you have to calculate what is this value f of 2 plus g of 2 plus 16 times of f of 12. Now in order to evaluate this expression here, what do you require? You require two things. One is the function. So here in this case, we require firstly f of x and we require g of x. So we'll first evaluate them. So in this case, we require these two things. So we'll first calculate them. So let's see this condition that we are given this integration from 0 to g of x t square dt is equal to 9 times of x plus 1 whole cube, right? So this is given to us. Now, in order to calculate gx from here, what is gx here? So this is required here. Right? So we wanted to solve this particular expression. So we wanted to solve this, right? And because the function here is appearing in the limits, we would have no problem while integrating this thing. Why? Because we already know what is the integration of t square with respect to t. It is t cube divided by 3, and here the limits are given to be from 0 to g of x, and the right hand side would be as such because no operation is being performed here, right? So we can very easily substitute the limits here. The upper limit is g of x, so we have g of x cube divided by 3 minus 0 cube divided by 3 is equal to 9 times of x plus 1 whole cube. So from here you have g of x whole cube is equal to 3 cube and x plus 1 whole cube, right? You can write 9 as 3 square. So you have 3 into 3 into 3, that is 3 cube. So what would be g of x from here? It is surely 3x plus 1. So you have one thing, you have the one function as g of x. This is 3x plus 1. Let's mark this as equation number 1. And here in the expression we require g of 2. So let's calculate that here only. So your g of 2 would be, so you can calculate your g of 2, that would be 3 into, in place of x we'll be writing 2, so that would be 2 plus 1, so that would be 3 into 3, that is 9. So your g of 2 is equal to 9, right? Okay, so now you have this thing. Let's mark this as equation 2. Now from the second expression, we are required to calculate the function f of x. So what is this second expression? We have integration from x cube to x square f of t dt. So let me write down here. Our second expression is integration from 0 to x cube plus x square f of t dt. This is equal to, let's see our expression once more. This thing is equal to x square, right? So now notice here in this expression, it is not as simple as to calculate here what is f of x. That is the question. So it is not that simple to calculate f of x. Why? Because in order to find what is this f of t, what do we require? We are required to get rid of this. So we wanted to get rid of from this integration sign, right? So how can we do that? We have to perform differentiation on both sides. So we have to perform differentiation with respect to x on both sides, right? And how can you perform differentiation under a integration sign? So to perform the differentiation under integration sign, we are having a result which is known as the Leibniz rule. We have the Leibniz rule. So let me write down and explain what is that rule. So whenever you wanted to perform the some integration where the limits could be variable or the limits could be constants that are according to the question that is given to you, and the function is given to be in two variables, say you could have a particular cases for all these cases, right? So here for this particular function, whenever we wanted to calculate the derivative for this particular integral, so what is this? This is equal to the integration with the same limits, but now we will firstly perform the partial derivative with respect to the given function of this inner function, that is f of t comma u du, right? If you do not know this rule, please do remember this. Why? Because this is very important, as in if you wanted to perform differentiation under integration sign in any case, right? So this is the rule. That means you will firstly perform the partial derivative for this inner term, right? And then you have plus the derivative for this upper limit. What is that? So that is the partial derivative of b of t with respect to t, and this function as such, we are in place of the variable, will now be writing the upper limit. So it would be equal to t, and instead of u will be writing the upper limit t, and minus the derivative for this lower limit. What is the lower limit? A of t in this case. And the function as such, we are in place of u will be writing the lower limit. So this is the rule. Now we will be solving and applying this rule onto our function. For our function, the lower limit is constant and the upper limit is variable, and the function here is unknown, that we are not that is not known to us a priori, right? So let's apply this rule here. So let me show you how we can proceed in this case. So here you can notice that our function is this one. So on the left hand side, we'll have, according to the Leibniz rule, the integration from 0 to the same function x cube plus x square, and the partial derivative with respect to now x, because our variable we are differentiating with respect to x and not with respect to t, right? So it would be the partial derivative with respect to f of what? F of t, right? And dt as such. This is the first term with us, plus the partial derivative with respect to x of the upper term, that is this one, that is x cube plus x square, and the function's value where we will, in place of the variable, we'll write this thing, and minus the, here we'll be writing the partial derivative with respect to x of the lower limit. Lower limit in this case is 0, and the function's value evaluated at 0. So this is our Leibniz rule here, right? So let's just solve this rule. This is for the left hand side, and for the right hand side, what was the right hand side? It is x square. So for x square, if we differentiate, that would be 2x. With respect to x, that would be 2x. Now you see, how can we solve this expression? So you are taking the partial derivative with respect to x for the function f of t. So f of t means it is a function of t only, and there is no such value containing x. So that means t would act as a constant, because that is a rule for partial differentiation. That means whenever we are performing partial differentiation with respect to x, all the other variables and quantities are treated as constant. So that means whole of this function would be a constant whenever we are partially differentiating it with respect to x. So this term, integration of 0 dt, it would be this one, right? And the next term would be the partial derivative with respect to x of x cube, so that would be 3x square, and of x square, that would be 2x, right? And the function's value, because the function is not known to us, so we have this quantity only, and the partial derivative of 0 is 0 only, so minus 0, that is equal to 2x, right? So this is the term here. Now let's next simplify this a bit. So this thing would be equal to 0 plus 3x square plus 2x multiplied with f of x cube plus x square is equal to 2x. So from here we are not actually getting f of x, but we are getting f of x cube plus x square, that is equal to 2x divided by 3x square plus 2x. So this is all that we obtain from this expression. So we'll be solving and using this thing further for our question. So in the question, if you see, what do we require? We are required the value of f of 2 and we are required the value of f of 12. So let's see how can we obtain that. So if you see, what is f of 2? Can you write f of 2 as f of 1 plus 1? And can you write this first one as 1 cube and the second one as 1 square? Yes, there is no issue. So that means you have your expression here in this form only, where what is the value of x? So this implies x is equal to 1. If x is equal to 1, what is the value of f of 2? It is equal to 2 into 1. In place of x, we are writing 1. So you have 2 into 1 divided by 3 into 1 square plus 2 into 1. So that is equal to 2 divided by 3 plus 2. So that is 2 by 5. So you have the value of f of 2 as 2 by 5, right? Next, you wanted to calculate the value of f of 12. So how can you write that? So can you write this as f of 8 plus 4, right? So can you write that as f of 2 cube plus 2 square? Why I am writing all this? Because I wanted my form as this one. So the same thing cube plus the same thing square. So here you see clearly that your x is equal to 2. So you have f of 12 as equal to. So in this expression you can now substitute your x as equal to 2. So you have 2 into 2 divided by 3 into 2 square, right, plus 2 into 2. So how much is that? That is 4, and this is 4 into 4, 12 plus 4. So you have 4 upon 16, that is 1 by 4. So this is the value of f of 12. So therefore finally what is your expression? So we wanted to calculate that from here. Let's see, what do we wanted to calculate? We wanted to calculate f of 2 plus g of 2 plus 16 times of f of 12. So we wanted to calculate f of g of 2 plus f of 2 plus 16 times of f of 12. So what is the value of g of 2 that we have already calculated? That was equal to this 9, right? That was equal to this 9. So let's substitute it here. 9. What is the value of f of 2? That is 2 by 5. 2 by 5 plus 16 times of f of 12, that is 1 by 4. So you have 1 by 4 here. So you can simplify this 9 plus 2 by 5 plus 4. So when you solve this, it would come out to be 13 point something. And what is that? You can solve and check. This is 13.4. So answer to this question is 13.4. So let's write the answer here. So the answer that we obtained here is 13.4. So I hope you understood this question. So here you have understood and learned about a new rule, that is the Leibniz rule, and that is a very important rule whenever you wanted to calculate the derivative of some integral function, right? Well, that is it for this video. Thank you for watching.